All right, so this is day 2 of 412 for Algebra 2. And we're going to start off by taking a look here we go, at this. So we're trying to solve 20x plus 1 is equal to 3 to the x. So we use that trick from the past few times, saying, well, let's graph the left-hand side, graph the right-hand side, and see where those intersect. So we graph them, and our calculator looks like this, right? So with these two lines there in this curve here, I don't see any intersections, so hey, there's no solutions to it. Now this is where your knowledge of kind of how graphs look and what they do really helps you know that, hey, there's more going on than I'm actually seeing. My window is just kind of skewed to the point where I'm not seeing what's actually going on here, right? I know that 20x plus 1 is just a linear graph. So this line goes straight forever and ever and ever, right? I also know that 3 to the x is an exponential. So this one has to be asymptotic and kind of goes almost horizontal as it goes further and further left. And then as I go further right, it starts to go up and up more and more and more and more steep. So by knowing that, I am guaranteed that at some point to the left, I'm going to have an intersection over here. And at some point kind of up and to the right, I'm going to have an intersection up over there. So I should have two solutions to it, right? So I can solve this by graphing it, or I can solve it algebraically, but there's a problem with doing it algebraically, which we'll get to here in just a second. But first, let's pull up Desmos and solve this with Desmos. So we're going to do 20x plus 1, and then we're going to do 3 raised to the x power. Right? So it looks like this. It's pretty skewed, but to get my other point, it's way up there. Right, so I see one there, and way down here where we cross at 0, 1. So I'm going to have answers of 0 and 4 as my x solutions. Again, my answer is the x value. It's not the point itself. The point is your answer only on a system here. All right, so not too bad. Now, one thing that it kind of asks us is, well, is what if I change this and say, at the very start, I subtract 1 from both sides and get this and this. Will that change my answers? Well, let's give it a shot, right? So if I do that, I subtract 1 from both of these. So that's now plus 0, and this is now minus 1. Right? Well, my intersections are now here and here, which is still 0 and 4. Because again, I only care about the x values. I don't care about the point itself. So I get the exact same solution, which kind of makes sense. Because if we're doing those basic algebra steps, we shouldn't ever be changing what our answer is going to be. So we should still get the same answer no matter how we affect or change those particular things. All right, so let's hop back over here and take a look at number 20. Okay. So on 20, we're going to once again try and solve this, right? And say, well, f of x is going to be 12 over x, and g of x is negative x minus 3 squared plus 4. So we graph that, and we get this thing over here on the right. Okay. So we see that we're going to have two answers here at A and B. Awesome. Let's go ahead and find out what those are. So let me go ahead and clear out these, and then get this back in the normal mode. Okay, so we're going to pull up Desmos. Okay, we are going to graph. The first graph was 12 over x, and then the other graph was negative x minus 3 to the second plus 4. And that was basically the graph that I saw on the example. And my answers are there at 3 and 4, because again, I only care about the x values, not the point itself. Well, awesome, great, done. I got two answers, 3 and 4. But there's a problem here, right? Again, knowing what these graphs should look like and should do is really, really going to help us out. So I know that this rational graph is going to kind of follow down and be an asymptote as we kind of get nearer and nearer to this y-axis, right? I also know that this parabola will get wider and wider, wider forever and ever and ever. So I'm guaranteed that my purple and my black line are going to intersect at some point. Let's go and find where that happens. Lo and behold, there it is. It's just off my actual window. If I didn't know from kind of knowing what the graphs kind of do, that I should look down further, I may have missed that. And that's one of the big kind of key things we are looking for here, is having that base knowledge of what graphs should kind of look like in general, not necessarily specifically. It's going to help us to know where to look to find all of these answers. All right, so then let's hop back to this. And that is it for day 2 of 4.1.2. So take that down, work on that, and I will talk to you guys next time.